indices is. Alright, so we know that an indices is a math term in which it allows compact numbers. If we were to write 4 times 4 times 4 times 4 times 4 times 4, right? And a compact way of doing this is to say 4 to the 1, 2, 3, 4, 5, 6. This would be equal to 4 to the 6th power, right? And that is us writing that number compactly. We also know that if we have a number 144, we can write this in the index form, which is 12 squared, right? We also know if we have 64, it's also write the number compact, which is 2 to the 6, okay? And that's, in looking at this number, the 2 is our base, and the 6 is our power, our index, are our exponent. A different name, but all have the same meaning, right? So we shall move on to our second law, which is the law of division. And that is when we divide quantities with the same base, we subtract the denominator index from the numerator index. The general formula says a to the m divided by a to the n is equal to a to the m minus n. Okay. Alright, so let's test this equation. So we have x to the 5th power divided by x to the 3rd power. Alright, so what we're going to do is to turn this into fractional. A fraction equal to x, these are dot separated, the multiplication, to 5th, 3, 4, 5th. This is divided by x. Okay. Alright, so what we would have here, seeing that the formula says we are to subtract the denominator from the numerator index. Say 1, 1, 1, 1, 1, 1. And our answer would be x to the 2nd power. Right? Which is the same if we were saying x to the 5 minus 3. I know that would be equal to x squared. Alright, looking at another example, we have x3 divided by x to the 7. Okay. Alright, so we're going to turn this now into a fractional. X, x, x. In the denominator we have x, 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 x. Okay, 1, 2, 3, 4, 5, 6. Alright, so it's another one. Let's draw our line. Alright, and we know where it's to still subtract. Down, Seeing that the x is in the denominator position, our answer would be x, the negative, seeing that it's below 1, 2, 3, 4. Right? Which is implying that if we say x to the 3 minus 7, that would be equal to x to the minus 4. Alright, our next example that we will attempt Alright, let's use one with some numbers. 15x 4 divided by 5x to the 3. Okay, that is equal to, alright, so we have our 15, we have our x, let's put the x, let's try to rewrite this, or 5, x, 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 alright, so we know we can cancel, 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 5 into 5, 1, 5 into 15, 3, right here we would have equal to 3x, okay, and this is similar if we have our, we know 15 being divided by 5 is equal to 3, right? Then we would have our x, this 4 minus 3, and this would be equal to 3x. Okay. Alright, so we have another example on the paper. So we have m to the 6 being divided by m to the 2. So that can be m to the 6 minus 2 equals m4. Alright, so those were a few examples in using the second law, which is the division law of index, which says a to the m divided by a to the n is equal to the a to the m minus n. Right? And we saw in which if we have, for this example, 3 to the x divided by x to the 7th, we'll still apply the formula in which it says x to the 3 minus 7, that gives us a x to the minus 4. This one we're dividing same base, different index. So we can divide the 15 by the 5 and we get 3. By the x to the 4th, by the x to the 3rd, we get an x, and the answer is 3x. Okay, thank you for joining us in our video today, in which we went through a few examples using the second law of index, which is the division law.